everyone, in this video we are going to determine the number of solutions that various system of equations can have. Please remember that when we say solution to a system of equations, it actually refers to as the point of intersection between the two graphs. So what do we mean by the word point of intersection? That's actually the point where the two graphs are touching each other. So point of intersection means that's where the two graphs are meeting at the point. Now, algebraically, point of intersection or solution to the system of equation is that these are the points, values for x and y that would make the equation true. Let's take these three examples here. Determine the number of solutions to the following system of equations using graphical method. Let's take this first system right here. On the side, you will see the graph of these two equations, and we can see that the blue parabola, which is the first equation, and the red line, which is this second equation right here, are not intersecting. So that means they are not touching each other, which means that since point of intersection or the point where they're touching each other refers to the solution to a system of equation, since these two are not touching each other, go ahead and say that these two equations that we have here, they don't have a solution. So we can go ahead and say no solution. Again, the reason for that is because they are not touching each other. And solution refers to the point of intersection or the point where the two graphs are touching each other. Now let's take this second example right here. On the side, you will see the graph of these two equations, and we can see that this blue circle, so the circle that we have here, and the red line are touching each other at one point, and that point is 0 and 3. So pretty much this 0, 3 is the point of intersection, and this 0, 3 is actually the solution to these two equations that we have here, or graphically, 0, 3 is the point of intersection or the point where the graph are touching each other. So we go ahead and say that this system that we have here has one solution. So there's only one solution because there's only one point of intersection. Now, when we go into algebraic method to check if this solution is really correct, I'm going to show the work right here. So what are we going to do right now is we're going to check if this 0, 3 would work for this, because we already have seen that on the graph that this 0, 3 is actually the point of intersection or the solution. But what about graphically? How do we test if this is really the correct solution? So what are we going to do is we are going to check, and remember the trick in checking for a solution, or checking for answers, we're supposed to change the variable into a parenthesis before we plug in the values. So if we were to do the first one right here, so I'm just gonna divide this into two. So let's take the first one. Remember, this is our x and this is our y. So what are we doing is we are testing it algebraically if this solution works for these two equations. So we start with the first one, so that would be x squared plus y squared is equal to 9. Again, remember, when we check, we change the variable into a parenthesis. So that is a parenthesis squared plus parenthesis squared, is that equal to 9. So then we plug in the values. Our x is 0, so I plug it in here. Our y is 3, I plug it in here. So 0 squared is 0 plus 3 squared, is that equal to 9, and 9 is equal to 9, which means that this 0, 3 is a solution to the first one. Now it has to work to both of them. So then we go ahead and check this 0, 3 to the other one. So we go ahead and rewrite this equation right here. So y is equal to 3. Again, the trick when we check is to change the variable into a parenthesis before we plug in values. So then we go ahead and change this y into a parenthesis. Is that equal to 3? So we're not sure of that yet. So we go ahead and plug in the y, which is 3. So we can go ahead and say that 3 is equal to 3, which means that this solution 0, 3 works for both of them, both algebraically. This is the algebraic method, and the graphical method was the one that I showed you a while back. So that means this solution we have here is correct. Now let's move on to the next one right here. On the side, you will see the graph of these two equations. So we're referring to these two equations right here. And we can see that this blue and red parabola, so both of these are parabola. So both the red and blue parabola are intersecting at 2 points. And these points are -2, 4. And the other solution is 2, 4. So that means these two graphs are touching each other at 2 points. So pretty much there's gonna be two solutions for this. So a system of equation can have no solution when they're not touching each other. It can have one solution when the system is touching only at 1 point, or it can have two solutions when the system or when the equations or when the graph are touching at 2 points. So that is the graphical method. We've seen that it works. It has two solutions. Now let's check these two solutions here using algebraic method. So we will check first the first solution that we got there, which is -2 and 4. So we're checking each one of them one after the other. So we're doing the -2, 4. Remember, this is our x and this is our y. We're checking the first solution first. So I am going to use the first equation right here. I'm going to write it down here. Y is equal to x squared. And then the other equation would be y equals -x squared plus 8. So then I am going to use the trick in checking our answer. The trick is to change the variable into a parentheses before we plug in the values. So then I will change this into parentheses is equal to parentheses squared. And now I'm ready to put in values. Our y is 4 and then the x is -2. So then I will do the math here. So that is 4 is equal to we're not sure of that yet. So is that equal to -2 times -2 is a positive 4. So then we can go ahead and say that this solution -2, 4 works to the first equation. But then when we say solution, it has to work to both of them. So we are checking it as well to the second equation. So this would be, again, the trick is to change the variable into a parentheses before we plug in the values. So that's parentheses. Is that equal to negative parentheses squared plus 8? So then I put in the values. The y is 4, so I put in 4 there. And then the x is -2, so I put the -2 here. So others are going to say like, oh, why do you have two negatives now? So the other negative was in front of the x squared. The other negative with the 2 is actually the value of the x that I plugged in here. This is the reason why I give you this trick to always change the variable into a parentheses so you don't mess up with the math. So then we can go ahead and simplify this. So this would be 4. Is that equal to, that's going to be negative. -2 times -2 is a positive 4 plus 8. So then I go ahead and say that this left side is 4. So this is 4 is equal to -4 plus 8. So then we're not sure of that yet. 4 is actually equal to 4, which means that this -2, 4 works to the first equation and it works to the second equation as well. Now, others are going to say, like, what about if it works to the first equation and it doesn't work to the second? That means that is not the solution. So a solution means it works to both of them. So both x and y would work to both equations. Now, our next task is to check this using the second solution that we have here. Again, we're doing the algebraic method of checking to see if these solutions really work for the given equation. No problem with graphical method because we can just go ahead and use decimals to determine the point of intersection, which is actually the solution. But for the algebraic, we have to plug it in and see if that would work. So we are done with the first solution. Now let's check the second solution. So I'm going to show the work up here. So we're doing the second solution, which is +2 and 4. So this will be our x and this will be our y. And then again, we are checking it to both equations because sometimes it works to the first equation, but it doesn't work to the second. So it has to work for both of them. So we're checking this one right here. So I will rewrite the equation up here. So that is y is equal to x squared. And then the other equation was y equals negative x squared plus 8. Again, the trick when we check is to change the variable into a parentheses before we plug in values. So I'm going to change this into parentheses. Is that equal to parentheses squared? So then the value for y is 4. And then the value for x is 2. So then I will simplify this. So that is 4 is equal to 4, which means that this solution right here works to the first equation. Now let's test it if it works to the second equation. Again, the trick is to change the variable into parentheses before we plug in values. Again, the purpose for that is so that we don't mess up with the math. So we are going to change this to parentheses. That is not equal to negative parentheses squared plus 8. So then the value for y is 4, and then the value for the x is 2. And so we simplify this, so that is 4 is equal to negative 2 squared is 4 plus 8. So this is pretty much like 4 is equal to negative 4 plus 8. So 4 is equal to 4. This solution right here works to both of these two equations, which means that these two work both algebraically and graphically. So that means this is correct. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. On the side, you will see the graph of these two equations, and we can see that this blue circle, so this represents a circle, and this red parabola here intersect 3 points. So that would be at the 3 points are negative 3, 4. That's also a positive 3, 4. And it also intersect, or they touch each other at 0, negative 5. So pretty much this one has 3 solutions. We can actually check this algebraically by plugging in x and y to each of them. So these 3 should work, both graphically and algebraically. So that should work. Did you get the same answers as this? Good. Perfect. Now let's move on to the next one right here. On the side, you will see the graph of the two equations, and we can see that this blue circle and this red horizontal parabola are touching each other at 4 points. So there are 4 points of intersection, and these points are negative 4, 3. We also have 3, 4. And we also have negative 4, negative 3. And we have 3, negative 4. So there's like 1, 2, 3, and 4. So pretty much it has 4 solutions. Now, if we check this algebraically and plug in x and y to each one of them, all of these 4 points would work, or all of these 4 points would make this equation true. Did you get the same answers as this? Good. Perfect. Now let's move on to the last one right here. On the side, you will see the video of these two equations that we have here. Both the blue and the red graph, they're both parabola, are actually on top of each other. So they match up. So they just come in different form. This one is in factored form, and this one is in general form, but then again, they are actually equivalent equation. So what does it mean when they are on top of each other? Please remember that a graph or a line or a curve are actually made up of infinite number of points. So which means that it has an infinite solution. So it's gonna be infinitely many solution. So there's going to be a lot of solution for these two equations right here. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!